In this section, we're going to look at learning objectives A, C, and D together. We're going to talk about stating translation rules when we shift graphs, and we're going to talk about the phase shift and vertical shifts, and then we're actually going to graph them. So let's do some review, something similar to Chapter 3 on translations. So here's four equations here, and I want to know which words would you put with it. So if you remember, again, in the equation, the x is always backwards. When it's all on one side, the y is the same. Be very careful here. This plus 14 is grouped with the x, and this minus 14 is grouped with the x. So here's what I know. Equation 1 here actually is having it move left 14. Equation 4 means right 14. Now, these other plus 14 and minus 14 is not grouped with the x, otherwise you'd see parentheses around it. This is the y movement. Y is exactly what we see, so this plus 14y is actually going to have it move up 14. This one here is down 14. So let's recall what a translation is. Remember, it's a translation or a slide, because of that SL might help you keep it in mind that it's a slide. And you're just going to add and subtract. What you're seeing here is they have taken, it looks like the parent cosine function, and it looks like they slid it, possibly they slid it forward this way, and we see another graph. What they've done here is they slid it left and right. When you slide the graph left or right, we actually call that a phase shift. So make note that is for right or left movement. That's a horizontal slide. So horizontal. Now, what if you slide it vertically? That's called a vertical shift. So a vertical shift is going to be up or down, and it already has the word vertical in it, so you can keep it straightforward. Now, something that's kind of interesting is the relationship between sine and cosine. If we look at this red graph, just one cycle, if we go from 0 to 2 pi, which is right here, you're going to notice that the S shape is sine, so this is the sine function. Now, cosine starts here, and it ends at 2 pi, and again, that makes the C shape, so we have the cosine. What they've done is they actually took the cosine graph, and in the equation they said do x minus pi over 2. So remember, if I had to write a translation rule for this, the equation's backwards. So what they're really doing is they're adding pi over 2 to the x's. They're not doing anything else to the y's, so there's no activity there. We'll put in words what this says to do. This says shift it horizontally right pi over 2. So what they did is if you take the blue graph right here of cosine, and if you were to shift this blue graph right here, if you shift it 1/2 of a pi, this point right here actually lands there. Okay? This point right here on the blue will land here. What happens is the cosine function actually becomes the sine function. So this theorem says that sine and cosine can become each other if you just shift them either left or right, depending on which one that you want. In this case, what we're seeing is, again, they took the cosine, they shifted it forward pi over 2, and it became the red graph, which happens to be sine. Okay, let's put it all together. If we look at this equation, we're going to first identify what the parent function is. The parent is just y equals the sine of x. So I'm actually going to sketch that really quick. Remember, the sine function is an S shape. It starts at 0, ends at 2 pi. Halfway in between is 1 pi. Now, its top amplitude happens between 0 and 1 pi, so it's a half. And then between pi and 2 pi is where it bottoms out. So that's one nice cycle of the parent. Now, what happens to the graph? Let's write the ordered pair rule. In the equation, it's x plus pi over 3, so it's really x minus pi over 3. And there's nothing for the y. So what's actually happening to this graph is what you see here in the ordered pair. This thing is actually moving left pi over 3. If they asked you to state the phase shift in words, you could say it was left pi over 3, or mathematically minus pi over 3 means the same thing. So let's sketch it. Okay, how do you do it? Easiest way to do it is take the 5 key ordered pairs that we've already graphed here on our parent function and literally move them this way. So I'm going to take this ordered pair and move it back 1/3 of a pi. So 1/3 of a pi is roughly going to be there. Take the second one and move it back, this third, take the fourth, and then the fifth. If you connect them, you'll get the blue graph, and that is how you can graph this phase shift by hand without a calculator. Okay, let's look at this one. Here's another equation. This time we have 2 sets of numbers, so there's 2 things going on. There's going to be a horizontal slide and a vertical slide, it looks like. Let's do the ordered pair rule first, or the translation rules. So here it says x minus pi over 3, so x is always backwards. So I'm going to write this a little bigger. It's x plus pi over 3. Now this plus 4 is with the y, and it's just what it is because it's on that particular side, so it's really y plus 4. Now if I wanted to, I could actually move the 4 over with the y, so I would subtract it, and the equation would have looked like this. Now the FST book would say, okay, when it's grouped with its appropriate letter, here it's y minus 4, I always do backwards, so it's y plus 4. It's another method. Okay, now in words, what is the phase shift? The phase shift is right pi over 3. The vertical shift is going to be up 4 units. So let's sketch it. We're doing the sine function again as a parent, so I'm going to sketch the parent function real quickly just to get the right shape and the key points that we want. Now in translations, it doesn't matter which one you do first. I'm going to actually go and do the vertical shift first. So I'm going to take all the ordered pairs that I see and move them up 4. So this first one's at 0, I'm going to move it up 4. This one's at 1, I'm going to move it up 4. This guy's here. This one moves there, and the last one is going to be right there. So this blue sketch here represents just the vertical shift. Now let's add the phase shift on top of that. I need to move it right pi over 3, so take each pair and move it over about 1/3 of a pi. And when you do that, we're going to get something like the green graph, and we've sketched it. Let's do another one. This time we're switching over to cosine. So there are 2 things going on in here. The parent function again is just the cosine of x. So let's do a quick sketch of the cosine. That's a C shape from 0 to 2 pi. Halfway in between 0 and 2 pi is 1 pi. That's where it bottoms out. And then it crosses the x-axis on the other 2. And that's our cosine function. Let's do the translation rule. The translation rule, what's really happening to the graph is not x minus pi, but x plus pi. And it's the same for the y, so it's y plus 1. So in terms of this, letter D was the correct answer. Now this one I'm going to graph the new one all at the same time. I'm going to take each point and do 2 things at once. I'm going to move it right pi and up 1. So let's take this first point, and if I move it right a pi unit, that would be all the way here, and then up 1 would be there. So let me plot that point. The next one, I'm going to take the ending point. I'm going to start here. I'm going to go right pi units, so that's 3 pi, and then up 1 would have me be right here. Well, what I can do, again, is take this one, and that's going to go to 2 pi and up 1. So it'll land me there, and then the 2 other points are going to be in here. And if I sketch it, that's a good graph of this cosine equation. Now if they ask me, by the way, what's the phase shift? The phase shift on here, I'll do numerical, is plus pi. The vertical shift on there is plus 1. So what we're doing is right pi and up 1.